Geometric sequences. We just got finished talking about arithmetic sequences, and we learned that in arithmetic sequences, the terms have a common difference. Geometric sequences differ in that the terms have a common ratio. In this slide, we've put examples of arithmetic sequences and geometric sequences side by side so we can examine the differences. Just like we have the formula a sub n is equal to d times n plus c for arithmetic sequences, there's also a formula that describes geometric sequences. And that is, a sub n is equal to a sub 1 times r raised to the power of n minus 1. Let's break this down and analyze it a little bit. If we take a look at the following sequence, we can see that we have the terms 7, 14, 28, 56, and 112. We can also write it as follows: n sub 1 is equal to 7, n sub 2 is equal to 14, and so on. Just like we found the differences between the terms for arithmetic sequences here, we can find the common ratio between the terms of a geometric sequence like this. Note here that instead of finding the difference, we're dividing each term by the term before it, and we see that if we go down the line, in all cases the ratio is 2. And so that's constant, but it's not a difference, it's an actual ratio. Because if you'll notice here, you see a pattern that each successive term is twice the term before it. But the good thing is that we don't have to see that. Based on the information we have, we can write the formula for this particular sequence as a sub n is equal to a1 being the first term, so in this case 7, times the common ratio, which we've already determined to be 2, raised to the power of n minus 1. N in this case happens to be whatever term we're looking at. So since we're looking at the term n1, or 7, n would be 1 in this case. If we were looking at the term n2, however, the formula would still read a sub n is equal to 7 times the common ratio, and that would be raised to the power of 2 minus 1. And if you work the math on that, you can easily see that you'll arrive at the answer that we have in this sequence for any given term. And that's really all there is to geometric sequences. The good thing is that both of these sequence types are pretty simple and straightforward, but make sure you work the quiz and test problems just to reinforce the concepts. These are usually pretty easy points on quizzes and exams, so you don't want to miss them. Let's break here, come back and move on when you're ready.